Hi, this is Russ Anderson. Today I'd like to run through some of the new lens solving capabilities in SynthEyes 1806. These are the first phase of some major enhancements in the lens modeling capabilities of SynthEyes. So I'm going to use this older GoPro sequence, and of course the GoPros have a bit of fisheye lens to them. So with SynthEyes 1806, we're going to be able to calculate that just from this shot without any pre-calibration, any lens grids or anything like that. And after we do that, we're going to export to After Effects. So we're going to start out just with a simple auto track of it, and we're not going to really work on the trackers that are produced. They're reasonably plausible. If we switch over now to the solver panel, you'll see that down by Calculate Distortion, there's now a More button. We click the More button, we bring up this Advanced Lens Control dialog, which has a whole bunch of additional controls. And up at the top, you'll see that not only is there the quadratic distortion that SynthEyes has done in the past, but now there's also cubic distortion, quartic distortion, and a bunch of additional controls for centering and for anamorphics. And right now, through the SynthEyes lens workflow, really the distortion terms up at the top are the ones that are presently supported. The lens workflow will probably get a little update, which might have happened by the time that you watch this already, to do the lens centering as well throughout the lens workflow. The ones down at the bottom are primarily for anamorphic lenses. They're kind of experimental at this point in time, and you'll see some additional developments in the next SynthEyes version in this area as well. You'll also see that there's rolling shutter down here, and SynthEyes can compute the rolling shutter coefficient directly from shots like this, and when rolling shutter is present and significant. Of course, if you're going to take advantage of that, you need to be using a 3D renderer downstream that also supports rolling shutter, and that would namely be Lightwave. So now let's go back to action here. We're going to just set up initially a coordinate system for the shot in advance. So we'll just set up a ground plane. Now let's go back to our solver view, and we'll start out just by solving the shot with no distortion. And you'll see that it comes out with a bit over 3 pixels of error. So that's a fairly high error due to that distortion. So now we can start turning on some of these additional terms and watch what happens. So now just from the quadratic, you'll see that that cuts that error about in half, down to 1.5 pixels. Now there are a bunch of different approaches that you could do at this point, and one of them is to start turning on additional terms and using refine. It turns out it's actually probably cleverest to just go and redo the solve from scratch each time to get the best overall results. And that's just because the solves can tend to be a little bit sticky as far as liking what they've already got. So if you start kind of from scratch, then you're likely to get the best results. And one thing I'll point out that you'll see throughout this, I'll be flipping on and off some of the different terms here. And if there's a non-zero value here and I'm not calculating one of the terms, that value is going to be taken as a given, as a non-zero given, as if we've already computed it previously, which may in fact be the case. And it won't update the value, but that distortion will still be used. So when you're going and playing around with the different distortion terms, then you want to make sure that if you're turning off the distortion, you might want to right-click it just to reset it back to 0, or as I tend to do here, just use undo to roll back. So a key point here is really not to go and just turn on all the boxes and see what happens. And the reason for that is that you can get what's called overfitting, where the numbers go down as far as the error in the scene up here, but the solve is actually worse. And that can happen when you don't have enough trackers, when there's not enough motion in the scene. You can actually have a situation where it's not possible to distinguish between what's happening as far as the motion of the camera and what the distortion is. And you can wind up computing distortion values that perfectly explain the tracker data that you have, but aren't actually describing well what's happening in the scene. So we'll see in a little bit that you can actually check up on that. But just for starters, let's just run through and look at what's a reasonable sequence here. If we go and turn on the cubic, and now we'll see we're down underneath a pixel of error. Now we'll just roll back again and switch to quartic. We'll see with quartic, there's a bit over a pixel of error. I'll point out just that the optics people will tell you that cubic distortion can't exist, that can't happen, and it should all be quartic. But as you can see, the real world really doesn't necessarily agree with what the optics calculations might have to say in theory. So again, we'll just roll back, and now we'll turn on all three of those terms and let it run. And you'll see now you get an even lower error, which is good. But a caveat to this is that if you look at what the distortion values are here, you'll see that actually they have increased substantially over what we had before when we were calculating just the quadratic and just the quartic and just the cubic. And this is something that you need to watch for. Here we've got a lens that does in fact have a significant amount of distortion. It turns out if the lens is actually better, has less distortion, these values can increase even more substantially. Because if you look at the pattern of the signs, there's a negative value for the one, then there's a positive, then there's a negative again. And basically, one of them is canceling out the next, and they're trying to get exactly the best result by having these large values that cancel each other out. And that's not really a good thing. And again, it's telling you that if you see a big increase here, you shouldn't really be using that many distortion terms. It's just chasing its tail. And you should just back off and just use a lower order term. So here, we've got a lens with a bit of distortion. So we can roll with that. Now, just a side note on this. Maybe at this point we'll go and let's just drop in a cylinder here. And I'll point out that, the distortion is being applied to the mesh in order for this to happen, so that the mesh is integrated into the distorted footage correctly, and it's being distorted. And there is a bit of a side effect to that if you have very large meshes, the process starts to take longer to display that when you've got this cubic and quartic distortion present, or any of the others. It will start to take longer to display them. It has to obviously do more work to handle that. We've got them all on. Let's take a look at the overfitting that I mentioned previously and how you can check for this. So to do that, what let's do is just pick out a couple of trackers here. And we want to make sure that they're ones that are reasonably lower to start with. If they're bad, then the point of this is going to get lost. So I'm going to pick out some trackers that are scattered throughout the scene and that do get out there towards the edges of the image. I don't want to pick too many, or there's going to be too few left to do a good result. But what I'm going to do is flip over here to the trackers panel and make these guys zero-weighted trackers. So the point of a zero-weighted tracker is that it's no longer used as part of the solving process. But after the solve is done, its best position is calculated and produces an error. So by setting up these zero-weighted trackers, those can be used as a cross-check on the solving process and the fitting process that we've done here to see if the error is really going down independent of the actual trackers that we're using. So these zero-weighted trackers are kind of standing in and substituting for what's going to happen when you add something like the mesh into the scene as a whole at locations that aren't part of your tracking set. So if we just had a couple of trackers here and did a whole bunch of very fancy fitting, then we might create the overfitting where the fit describes exactly what the tracker data is doing, but not what the rest of the scene is doing. So these guys are canaries, if you like. They're little canaries in the mine that tell you what's happening in the scene. So let's go back and do this process again. So we're going to turn off the different enables. We'll run the scene again. And now what we're going to look at is not only the error up here in the scene as a whole, but you'll see that when some zero-weighted trackers are present, there's this canary error that's printed out. It's just the average of the canaries in the scene and how much error they are. And remember, they're not being used to generate the solve, but they're being used now to check up on it. So we're sitting out here at 2.33. Now let's go and run it again. And now we see that the canary error is in fact decreasing. And we'll just go ahead and continue to turn them on. There's 0.82. That's just a right click, by the way. Again, with the quartic, it's sitting up at 0.9. And now here we're back with all of them on. We've got the average scene error down to the 0.9 again. And our canary error has continued to decrease this entire time. So that's a good thing. That's telling you that you're not overfitting, that you're doing a good job of identifying what the amount of distortion is in the scene and not overdoing it. In your other scenes, if you have fewer trackers, less motion, you might see that canary error increase. That's telling you you need to back off, not compute some of the distortion terms. That even though the error may be lower, really, as far as the scene is concerned, it's not better. Just for fun, we can turn on the lens centering, and you'll see that it drops down the errors maybe a little bit more, but not super much so. Which is why some of those lens center numbers aren't generally very accurate nor helpful. Once we have the solve locked down, we're ready to do the export. Before we do that, we need to take a look at the lens workflow. What we're seeing right now is just kind of what you get as a result of the solve process to start with. Let's go over to the perspective view and you can get some idea of what's actually going on. We've got this image that ultimately has been undistorted quite a lot in order to have everything match up, which it does in the perspective view as a linear shot. And we're going to want to export kind of in this format to our downstream applications so that they can insert 3D effects into them. And for the case of After Effects, it can do the undistortion locally, have the 3D effects added in, and then do the redistorting locally within After Effects. So we're going to set that up using the lens workflow. Again, here's what we have there. We'll hit the lens workflow button, and that gives you two different choices corresponding to two different workflows of what you want to deliver ultimately. If you want to deliver footage with no distortion in it whatsoever, that would be something that looks roughly like that. That's the first single pass workflow. The more typical one for this kind of shot is a two-pass workflow where you're going to undistort the footage, do something in 3D, and then redistort it back so it looks like the original. And that's what we've got here. Now, in SynthEyes 1806, there's a new option for how you do the formatting of that undistorted version of the image. Previously, you could have a couple of pixels around the outside edge of the image, and SynthEyes would generate a final result image that could be some fairly arbitrary size that would change each time you did the export, depending on what the underlying distortion values that were calculated were. But in 1806, there's also now an option to be able to have a fixed value here for this margin. This is in percentages. For this kind of a shot, we actually need quite a large value to be able to encompass the entire undistorted shot. More typically, for shots, with reasonable, really non-fisheye lenses, people would use something like 10% there. And that way, you get some nice round numbers and you don't have to worry about the size changing depending on what particular distortion value you have in a given shot. Here we're going to use this 80 just to show what happens. And obviously ahead of time I figured out that the 80 corresponds to what's necessary for this shot. You'll see that it extends right to the edge of the image, and you'll see it actually goes up to it. And these pixels around the edge, by the way, are actually kind of expanded ones that are to help compositing downstream a little bit. So the original image is being brought out to the corners. We could go with an even bigger number if we were so inclined, but that gets a little silly. If the distortion on a fisheye lens is too large, by the way, then you do need to switch to using 360 VR processing. The fisheye processing as a linear camera like we're doing here is maybe good into the 120 degrees, 140 degrees, something like that. But obviously with a conventional linear lens, you can't go past 180 for sure. And as you get close even to 180, the total image size that you would need just blows up, millions of pixels and stuff as you get closer and closer. So that's silly, and at that point you need to be using 360 VR techniques to do it, which I won't really address here. But for now, we've got our modified version of the image. This is now being done by the image preprocessor in SynthEyes. We could output this image directly to other applications that don't have their own lens distortion and undistortion capabilities, but After Effects does, so we're just going to use that. So at this point, I'm just going to go and we'll do the export, and we'll do After Effects JavaScript, and there's our previous version of that we'll just overwrite, and I'm using pretty much default parameters. I'll point out right now I've got After Effects just sitting in the background waiting for something to do. So we've just told it to open up as part of that export, told export After Effects to read in the scene, which it is now done. And you can see we've got a 3D environment set up within After Effects. And if we look at this comp, this is the 3D comp. And it has on it a SynthEyes Undistortion and Distortion plugin on it that knows how to use SynthEyes generated coefficients. And you need to be sure, A, to use the SynthEyes plugin, because these numbers are not the same. You can't just plug them into something else and expect anything to work at all. But also you need to be sure that you use the version of this plugin that's included with SynthEyes 1806. It has the additional quartic term added to it. So just be sure to install that into your After Effects. Otherwise, when you try and load a scene, if you have the earlier version, it's going to toss out some error message and you're not going to know what's happened. So that we've got the 3D comp there, and there is also the version that redistorts the 3D to produce the original image as well. So this comp is what you can use to generate redistorted output from within After Effects. So you're doing all the undistorting and redistorting inside of After Effects. So that's all part of the standard lens workflow stuff in SynthEyes, and that's a whole topic of its own right that I invite you to check up on with some of the other tutorials and the manual as well. So the part that's new to this now is that we've got a whole lot more things being calculated within SynthEyes directly that we can pass down to After Effects as well. I hope that you have learned a lot here. The lens modeling stuff is a work in progress that we've set up a bunch of capabilities now inside of SynthEyes that we'll be able to use for some additional lens modeling in the future. Stay tuned for that. And in the meantime, here you go. This quartic and cubic distortion terms, I think, are going to be really helpful for people using drone footage and the action cam sort of footage like these GoPros. So thanks for watching. Have a great day.